This currently is the battery monitor or solar charge controller of our camping car. The only thing it does show is that the solar panel is producing electricity, which is being shown by that blinking arrow, and it's showing 13.1 volts battery voltage. Unfortunately, it doesn't tell us anything about the state of the battery, so I'm installing a LiTime battery shunt. I'll be mounting it on the wall right there, and it'll connect down to the battery and tell us a percentage of how much battery we have left. And these are the two sub batteries, negative terminals. The shunt connects to the negative terminals and goes in between the battery and the camping car, and there it counts how much energy is flowing in or out, and it gives a very accurate percentage. So let's go ahead and open the package. This is the actual monitor. And this is the shunt. The red one is a power cable that has to connect to the positive of the battery. I don't really know what I'm looking at, so I need to read the manual. So after glancing at the manual, it's time to start connecting some wires. The shunt has a B for battery and a P for power, perhaps. So the B side has to connect to the negative of the battery, and all the other wires, anything that leaves the battery has to connect to the P side, power side. So the idea is that any electricity that leaves the battery has to pass through the shunt. If you connect something else to the battery directly, the shunt is not going to register it. So you cannot connect anything apart from the shunt to the battery, and then all the loads, all the lights, whatever inverters you have, need to connect to the P side of that shunt. So the shunt is basically in between the battery and your RV and checking how much electricity is flowing one way or the other way. So the cable is relatively short, and I have to make sure that I mount the shunt near the battery. And anytime you're working on the power system of the RV, you have to make sure that the cables don't touch each other or don't touch any metal part, especially when we're driving and the cables shift around. If any part of the positive touches the negative, it's gonna become a big problem. Smoke or fire or worse, so we need to make sure that everything is mounted securely. I'll be placing the mount on the cross, that cross beam right there, and drilling a hole, fixing it with a screw. After finding a good spot for the shunt, it's now time to take off the negative loads of the battery and connect them to the P side. Ideally, you would have a bus bar, which is a kind of a hub for connecting many cables and joining them together. I don't have a bus bar and there's not too many wires here, so I'm just going to be taking off all the negative wires from the battery and connecting them to the P side of the shunt. In the process of mounting this, I needed to find out which cable is for what. So I found that this cable on the right side with the conduit is the alternator charger. The one with the yellow tape on it is the solar that's coming in from the charge controller. And they're all going to the P side of the shunt. and then the B side of the shunt is connecting to the battery. So the shunt is connected to the negative, and that's good. It does need power though to power the display, and that means it also needs to see the positive part of the battery. So it comes with its really tiny flimsy cable that I connect to the positive terminals of the battery, and then the shunt will receive power and turn on the display. It was difficult after the fact to connect that small wire into the shunt, so that's something I should have probably done before screwing it down. Now it's time to connect the monitor to the shunt. It would have been good to connect this cable also before screwing the shunt into the frame of the battery compartment, because I'm struggling here to put it in. Once you connect the cables, the shunt turns on, and now it's time to set up. So here we go, I set up my battery shunt. I have a 200 amp hour battery, so I set it up to 200 amp hours. It's now 100% and the voltage is 13.4. You can see that it says at the bottom right plus, plus 14 watts. So that means the solar panel is currently producing electricity and sending it into the battery. The plus means it's charging. If that changes to minus, like right now, minus, so the fridge probably just turned on. Once the fridge turns on, it's drawing power from the battery, so now it's minus 33, so you're using 33 watts. It also says how many amps, so minus 2.51 amps. So the battery shunt doesn't tell you exactly how much battery you're using, you know, the fridge or the lights, and it also doesn't tell you how much solar you're producing. It gives you the difference between what's coming in minus what's going out, kind of a net value. So in this case right now, so we're using about 78 watts. I'm not sure how much the solar panel is putting in. I just can see that the battery is being discharged and I have 39.12 hours left of usage. Once the sun goes down and there's no more solar coming in, it gives you an accurate reading about how much electricity you're going to be using overnight, and you can tell roughly, if I wake up tomorrow, how much electricity will be remaining, or can I make it through the night. Especially for the batteries we have, which are lead acid batteries, they shouldn't be discharged below 50%. So I'm also setting an alarm to let us know at 50% we need to stop using the battery. I want to avoid drilling holes, so I'm just gonna mount it on that little ledge there, run the cable behind the sofa down to the battery compartment, and keep it like this for now until we upgrade the battery and upgrade other systems. So right now you can see, 13.1 volts and solar is being produced. That's the old monitor, and it doesn't tell you anything about the battery state. You have no idea how much battery is basically available for usage. And with a battery monitor now I can see, alright, so 13.1 volts, yes, but it's 100%. So I know that we have roughly 210 amp hours of battery capacity remaining, and usable is 105 amp hours. Thanks for watching.